In Chapter 9, we are going to learn about parabolas, ellipses, and hyperbolas. And in Lesson 9.3, we are going to focus on parabolas. You guys have seen parabolas in algebra, so we're revisiting that, although we are looking at a different form of an equation. If you glance down here, you can see we're looking at the standard equation, but if you notice, here's the parabola. You guys have seen this shape before. So it's slightly familiar, but with some new information now that we're in Algebra 2. So, our definition of a parabola is the set of all points in a plane equidistant from a particular line called the directrix and a particular point called the focus in the plane. So let's zoom in a little bit and take a look at this parabola. So the line that they were talking about, the directrix, is this line right here. That's the directrix. The focus is this one right here that kind of looks like it's on the inside of the parabola. And then you guys remember vertex from Algebra 1. Vertex is either the highest point or the lowest point of the parabola, and that is your vertex. So with a definition, what they're saying is that every single point on the parabola is the same distance away from the focus and from the directrix. So for example, if I were to just choose a point, let's say right here, the distance from this point to the focus is the exact same distance to the directrix. Those are the same distance. I could pick a point up here. The distance to the focus is the same distance from that point to the directrix. So that's what we mean by equidistant. Every single point on the parabola will have the same distance to the focus and to the directrix. All right, so we have some things to know here. Two parabolas. This one is opening up or down. These are the ones we're used to from algebra. Here's our standard equation, y minus k equals 1 over 4c times x minus h squared. These parabolas will open up or down. The focus, the ordered pair right there, has two numbers. The x value will be h, which comes out of our equation, and the y value is k plus c. So that k from the equation plus the c down there. The directrix is the equation of a horizontal line, so it's going to be y equals, and then that k, the number with the y, k minus c. All right, if we just quick look over here at our other parabola, same idea, just everything's on its side now. So you can see the equation looks just a little bit different, but very similar. Instead of the x minus h being in the parentheses, the x minus h is out front. We still have the same 1 over 4c, but now we've got the y minus k in parentheses. So if the equation starts out with the x, it is going to be kind of a sideways parabola, which means it's opening to the right or it's opening to the left. This one is opening to the right. And then the focus, that ordered pair, the x value is going to be h plus c, the y value is k, and the directrix, the vertical line, because it's vertical, that's why the equation is x equals, and to figure out the number that x equals, we just do h minus c. So this is kind of a lot here, a lot of little h, k, c's that we have to know, but we'll get the hang of this with some practice in our examples. So we're just going to take a look at these examples down here to start off. All right, in example 1, well, in all of these, you're given two of the above pieces of information are given. Find the third. All right, so when we do these problems, we always want to go ahead and draw a sketch of what we know. And what we know is the information that they gave us. So in example 1, they gave us the vertex and the directrix. Remember, the directrix is the line. The vertex is the point on the parabola. Your vertex is at 3, 2. So if I go over 3, up 2, this is the vertex right there. And I'm going to label that with a V. The directrix is y equals negative 2. So I'm going to go down 2. That's going to be a horizontal line down here at negative 2. That is the directrix. All right, so we know that the vertex is halfway between the directrix and the focus. So that means the focus must be up here. And how far up is it? Well, let's see how far away is the vertex from the directrix. 1, 2, 3, 4. So I'm going to go up 4 from the vertex. 1, 2, 3, 4. And that is the focus. That ordered pair, if we go over 3, up 6. Oops, that's a comma. So our focus is 3, 6. Our vertex was given to us as 3, 2. And that directrix was y equals -2. All right, so let's take a look at another one. With the given information, vertex is 0, 3. Focus is 0, 0. Let's find the thing we're missing, which would be the directrix. So we'll go ahead and draw a sketch of this. Vertex is at 0, 3. That's going to be up here. Go ahead and label that vertex. Focus is at 0, 0. Now remember, the focus is inside of the parabola, so I know that this parabola is going to be opening down like that. The vertex is halfway in between the focus and the directrix, so if there's 3 between your vertex and focus, I know that I have to go 3 in the other direction to get that directrix. So our directrix is the line y equals, because it's a horizontal and it's going through the y-axis, 1, 2, 3, 4, 5, 6. Our vertex 0, 3 we were given, and our focus 0, 0 we were given. All right, did we draw, sometimes I forget to draw the parabola. The parabola on the first one is going to look like this with that focus in the middle, opening up. All right, last one over here. We are given the directrix and the vertex. That directrix is x equals -3. So x equals -3 is going to cross through the x-axis, and that is going to be a vertical line. That's our directrix. Focus is at 2, -4. So I'm going to go over 2, down 4. That's our vertex. And then what we're missing is the focus, or what we have to figure out is the focus. So our vertex is on the parabola. The parabola will open away from the directrix, so I know it's going to open to the right, something like this. That focus is going to be inside that parabola somewhere. So what we do is we figure out how far apart the vertex and directrix are, and we're going to go that same distance to the right to find the focus. So let's go ahead and count. I'm going to kind of go up here to my x-axis. 1, 2, 3, 4, 5. So I have to go 5 more to the right. 1, 2, 3, 4, 5. And the focus is going to be right in line with the vertex, right there. All right, so our directrix was x equals -2, 3. Just kidding, -3. Our vertex is 2, -4. That doesn't even look like a 4. There you go. And our focus is, let's see, how far over did we go? 1, 2, and then we went 5 more, so that's 7, and then down 4, so 7, -4 is our focus. And our parabola is going to open to the right with that focus in the middle like that. All right, there's one more thing we need to add into our notes. When we get to our equations in the next few videos, we're going to be figuring out the C value, because C value is in the equation. So up here somewhere, I want you to write in that C is equal to the distance from the vertex to the focus. And that will make more sense in the coming examples. All right, so this Name That Tune is a guy I've seen in concert a couple times. Had an opportunity to meet him once and have a photo taken with him. And the song I'm going to play, it actually kind of has an interesting story. It's one of his most famous songs. So remind me in class and I'll tell you the story behind it.
When you're down and troubled and you need a helping hand, and nothing, oh, nothing is going right. Close your eyes and think of me, and soon I will be there to brighten up even your darkest night. You just call out my name, and you know wherever I am, I'll come running. Oh yeah, babe, to see you again. Winter, spring, summer, or fall, now all you got to do is call, and I'll be there, yeah, yeah, yeah. You've got